We're going to start with gyroscopic compasses because the calculations are easier and also the concepts are just a lot simpler. I could finish it in one sentence. The error present in a gyroscopic compass is just a physical mechanical error. Different types of gyro compasses work differently, but ultimately it's still just a gyroscope spinning at extremely high speeds within a machine, and then maybe different things like lasers are measuring the exact angle that the gyro is pointing to, based, I think, technically on the Coriolis effect. The point is, with something that precise and complicated, there's going to be little bits of wear, little imperfections in the machine, and that's going to cause it to sway off slightly from its true alignment. And that sway will change over time as the compass experiences more and more wear. So just to put it in perspective, this is also an extremely small error. Usually your gyro error, you can expect to never go more than 0.5%, probably somewhere between like 0.2 and 0.3 in any directions. It's not a serious deal, but it's still, you want to correct for everything. You want to always know that it's present. So with that in mind, and with the conception that you, let's say, went to cited a range, measured its bearing, then compared it off of the true range listed on the chart, you will now have two different values. So using the example from the last video, we'll do 060 and 059. So the bearing you got off of your compass was 059, but the true bearing that we know that the, in that case, the tower and the water tower were on was 060. So how do we find out how much the error is and in what direction it is? Well, we use a formula that we can just offhand refer to as GET, because it's just GET. It means gyro plus easterly error equals true. Easterly referring to whether the error is easterly or westerly. It's just the direction that it is going. And easterly error means that the true bearing was further along the arc of the compass than the gyro bearing was. I'll draw that out. If that's the true bearing, and that's the gyro bearing, this change in arc here, that's an easterly error. If the true bearing is over here, then it's a westerly error, and that's written out mathematically as the true bearing having a number that is higher, because obviously that's the direction that the compass moves in. So anytime you need to calculate gyro error, you can know that if you're adding value from your gyro to get your true, it's an easterly error. So in this case, the difference is obviously 1 degree, and we'll label that as 1 degree east. Now let's say we just reversed it, and it was 060 and 059. The total error is still 1 degree, but now you're going from the higher number to the lower number, so you're going this way, and that's a westerly error, so you would label it as west. So just remember, gyro plus east equals true. Gyro minus west equals true. So let's use just a set of different numbers to make it hit home more. There's your get. Let's say 240 and 235. So once again, first thing you do is just find the difference, which is 5 degrees. That's nice and simple. And now you look at your direction. Well, you're going down, so you know plus east is going up, so going down must be minus west. So this would be 5 degrees west. Another thing that could happen, you could say you had a bearing of 135 on your gyro compass. You don't have your true bearing, but you know consistently that your gyro error is, let's say, 2 degrees east. Well, now what's your true bearing? You put these two together, gyro plus east, so you add them, you get 137. Obviously, I'm going really in depth for what's a basic addition problem, but this is really all you have to do for gyro error. It's nice and simple, just one little calculation. All you need to do is remember the direction, and you can always quickly go from your gyro bearing to your true bearing.